Assalamu alaikum. I'm your science teacher again and again. I miss you all. I hope to see you soon. Today, inshallah, we'll finish the last part in our lesson, in this lesson, lesson 3, which is talking about energy transfer in collisions, energy, the ability to do work, transfer, move, or from one place to another. Collisions, which is collide or crash, or objects hit each other. Today, inshallah, we will describe the law of conservation of energy. So please focus with me, bring your book, open it at page 52, and come to explain. Let us revise our lesson vocabulary words. We learn together about collisions, examples of collisions, the meaning of collision in science, and we learn what transfer during the objects crash or collide, like these two cars when they collide to each other. Next, we learn about inertia, which is property or characteristic of an object that resists change in its motion. We said that if the object at rest tend to stay at rest, give inertia, your inertia, give instruction to stay at rest if you are at rest, or give instruction to stay in motion if you are moving, this inertia. And we explain the function of seat belt, and we said it's very important to wear it every time when you are in the car. And then we describe the momentum. We said momentum related to inertia, momentum measurement, how easy or difficult to stop an object moving. If we have object is moving, how difficult or easy to stop it? The measurement of this called momentum. And we said we can calculate it by multiplying mass with velocity, which is speed with direction. And we have conservation of energy and energy transfer. Today, inshallah, we'll explain the meaning of energy transfer and the law of conservation of energy. Look, energy transfer means the movement of energy from one object to another. The movement. When the energy moves from one object to another, from one place to another, from one system to another, from one body to another, this is called energy transfer. In the last terms, we learn different types of energy, like mechanical, thermal, nuclear, chemical, electromagnet, potential, kinetic, and many examples of types of energy. So, and we learn this. So, energy can transfer from one place to another place, like heat energy. If you hold a hot tea glass, the heat can move from the cup to your hand. Why? Because energy can transfer from one object to another. Or when I talk to you, you can hear my voice. Why? Because the sound energy can move from one object, from me to you. Also, the main example of energy transfer, the light and thermal energy from sun to our earth. Look, we have two objects, our earth planet and the sun. So, sun provide us with heat and light. So, because of transfer of these two types of energy, we can get light and sound. The thermal energy and light can reach our planet because these two types of energy, example of kinetic energy, which is can move from one place to another. So energy transfer means energy can move, or the movement of energy from one object like sun, like thermal and light energy can move from sun to the earth. Okay. Today we will learn about law of conservation of energy. If you remember in the last lessons, we learned that also in this lesson, at the beginning of this lesson, when we discussed together car crash, we said energy cannot be created or destroyed. This is called law of conservation of energy. We said energy cannot be created. We can't build or make energy, and it cannot destroyed or damaged or disappear. But what happened? Energy can move from one place to another place and can change form, transform from one type to another type. But the total energy is stay same, remain the same. So again, focus here. This is called law of conservation of energy. What is this law said, or what's the idea of this law? This law learns us energy, which is the ability to do work, which is we cannot see it but we can feel it, cannot be created or destroyed. If somebody is sitting and he has free time, he can't build energy from nothing, or destroy it, disappear it, or damage it. But what happened? Energy move from one type to another, or transform from one form to another. So, for example, when you eat food, you take chemical energy from this food, you store it in your body. This chemical energy is waiting you to move, and then it will change to kinetic energy. This chemical energy doesn't destroy, but what happened? It's changed to another form, which is kinetic energy when you start moving. You have to compare and contrast between conserving energy and law of conservation of energy. Look, conserving energy means using energy wisely. We have to save it, we have to protect energy, we have to keep energy, we have to reduce energy. How? For example, when you learn about the 3 R's, reduce, reuse, recycle, these 3 R's help us to conserve energy, to save energy. How? By using less of these resources. So, conserving energy means using it wisely. Okay, so you have to compare and know how are conserving energy and the law of conservation of energy different. Page 52, you have your lesson, conservation of energy. You can highlight, it's highlighted for you, highlight the meaning or the definition or what the law of conservation said. Look, it's the law that states that in a closed system, energy cannot be created or destroyed, but can be transformed from one type into another. Look at this picture, which is in your book, page 52. If you remember, first term, you had a trip to where? To IMG. There you were playing amazing game. Yes, one of these games was roller coaster. Some of you play it many times, and we said it's what? It's a very nice example of conservation of energy, law of conservation of energy, and show us how the energy transform from one type to another, how energy change from one type to another, from one form to another. Look here, we said, or you can see this car at the top of the roller coaster. When the car at the top of the roller coaster, it has what? The most potential energy. When it starts moving, this potential energy starts changing into kinetic energy. When it increases its speed, more potential energy change to kinetic energy, because more speed, that means more kinetic energy. But the total of the energy is remain same, doesn't change. The total of kinetic energy and potential energy at each point it's same, but what happened, the amount of kinetic energy and the amount of potential energy is change. Okay, you can read what's written about roller coaster and how the kinetic energy change into potential energy in which point, at which point. Look here, this very important point. The energy here cannot gain kinetic energy without losing. Okay, so highlights in your book. Roller coaster, for example, cannot gain kinetic energy without losing potential energy. But what happened? They gain potential energy at the top of the roller coaster and its decrease in speed. But the total of this energy same at each point. This which is called law of conservation of energy. The total stays same, but the energy changes from one type to another type. Also, in roller coaster, some part or some type or some amount of energy doesn't change into kinetic. It's lost energy, which is changed to heat and sound. It's called lost energy, not destroyed energy. It's lost energy. This energy doesn't change to kinetic or potential, but what happened is changed to another form, which is heat and sound through it the work of friction. Now you have a question in your book. Please, you have time, read it, try to answer it by yourself. How is energy conserved in collisions? What happened when remember that collision doesn't mean accident or a huge collide. It can be touch or hit between two or more objects. So the car with the roller coaster, how the energy conserved in this game or in collisions in general? So the answer is energy conserved in collisions because kinetic energy transforms into potential energy and some of it changed to heat and sound. So the total of kinetic energy and potential energy, heat with sound, all these energy at each point are equal because of the law of conservation of energy. I hope you understand our lesson. Understand the difference between conservation of energy and conserving energy. I hope you understand the meaning of energy transfer and example of energy transfer. To improve yourself, to develop your knowledge, to expand your learning, to evaluate yourself, I prefer and recommend for you this website, a quiz website, which is we will use it in the classroom. You can click on this website or search on Google about it. You can find it easily and solve the first quiz about conservation of energy. This will help you to understand more and more about our lesson. See you.